Welcome back, students. Today we are just going to see with the concept of forward error correction, chunk interleaving. We have already discussed about the forward error correction. So this is another technique where we are going to check out with the chunk interleaving. So actually this concept of chunk interleaving is going to be incorporated for the data, mostly of the multimedia data. So retransmission of corrupted and lost packets is not useful for real-time multimedia transmission. So in that case, we have to correct the error and reproduce or send the packet immediately. So here you can just see the schematic of how the data is being encoded using an encoder and how it is being transmitted to the receiver's end. So in this case, if you just observe, we can very clearly see that there is a loss of some data packets that is taking place. So how this is going to be overcome or how it is going to be detected is what we are going to see in the concept of chunk interleaving. Yes, we know that the forward error correction in multimedia is allowed to allow some small chunks to be missing at the receiver's end. So in this technique, each packet is going to be divided into chunks. So here we can just observe that the packet 1 is divided into some 4 chunks. Packet 2 has been divided into 2 chunks and packet 3 has been divided into 3 chunks. And the data has been transmitted only in the chunks to the receiver's end. So here the data is then created chunk by chunk. So here it is going to be created horizontally and it is going to be sent to the receiver's end. But at the receiver's end, they are going to be combined. That is, these packets are going to be combined vertically. So the data received in chunks and this is going to be the receiver's data. So here we can just observe this particular diagram. So here in the left hand side, you can just observe that packet 1 is having 5 chunks. Packet 2 has been divided into some 6 to 10 chunks. Packet 3 again another 5 chunks ranging from 11 to 15. Packet 4 16 to 20 chunks and packet 5 from 21 to 25 chunks. So now you can just observe how the transmission is being taking place at the to send to the receivers end. So packet 1, they are going to be transmitted vertically by taking the chunks. So sending column by column. So we can just observe 1, 6, 11, 16, 21, packet 2, 2, 7, 12, 17 and 22, packet 3, 3, 8, 13, 18 and 23, packet 4, 4, 9, 14, 19 and 24 and packet 5 is 5, 10, 15, 20 and 25. So they are going to be transmitted in this way. Now if you just observe the diagram below this, let us consider the third packet is being lost or corrupted. So now what happens over here is at the receiver's end, we can observe that all the packets have been transmitted and you can just observe the third column that is being lost. So in this case, what happens over here is one chunk in each packet is lost. That is the concept we have to take into consideration. So in one packet, one chunk is being lost. So this is going to not create a major data loss at the receiver's end. So this concept is going to be called as chunk interleaving. So you can just observe. So the carry is a chunk from several original packets. If the packet is lost, we miss only one chunk in each packet, which is normally acceptable in multimedia communication. But in this case, small chunks are allowed to be missing at the receiver's end. One chunk can be afforded and to be missing in each packet, though all the chunks, though it is like, if you just consider over here, comparatively, what happens over here is missing of one chunk is not going to create a big loss in the data. So this concept is